Hello everyone, welcome to Chapter 2. This is a particularly important chapter in our text and in the course. In this chapter you'll learn how psychologists know what they know. Where does this knowledge come from? So it will give you the tool to understand research in all sorts of science fields. And with that, let's begin. How do psychologists obtain their knowledge? Magazines, internet, secondhand sources. Hopefully you're not tempted by those answers. See if you can decide where we do get our knowledge, and then we'll see on the next slide. We utilize the scientific method. You are likely to have come across a scientific method sometime in your past. We're going to divide it into 4 distinct steps. Your previous teacher might have had a pre-step. If you had a pre-step, that's fine. You can certainly keep it. So let's take a look at these steps of the scientific method. So for our first step, we have develop a hypothesis. The asterisk means I'm going to have some cautions for you in the next slide based on common mistakes I see students make on tests. You cannot put the word hypothesis. It's a lazy answer. It's not a complete concept. So develop a hypothesis is a good answer, though you do not have to say develop a hypothesis for me. You could say, well, think of some different ways of saying develop a hypothesis, and I'll pause for a moment. Create a hypothesis, good. State a hypothesis, excellent. Formulate a hypothesis, you get the idea. So on the test, definitely tell me a phrase involving a hypothesis. You also need to know this hypothesis needs to be a statement, not a question. You'll see that on the next slide. And also, it must be specific. It's not sufficient to say that one variable affects another. How does it affect it? It makes it quicker, slower, bigger, smaller, and so on. So again, it needs to be a specific prediction. For step 2, you could put test hypothesis. That's a logical follow-up. Conversely, it's also very good to put gather data. Either one is good, but don't put both on a test. If you double list a step, it makes me think that you're confused. So choose one or the other, whichever you prefer. I've listed for you some of the different ways of testing the hypothesis: observational research, case study, survey, correlational study, experiment. So we have many options, including these, and some additional ones as well. The next step, you'll create a mountain of data. The next step would be analyze the data. Do you have to use the word analyze? No, you could interpret it. You can apply statistics to it, but you get the idea. More than just one word. Last step, and a lot of students stop there, and unfortunately they can't get full credit. The last step is to publish the results. Can you share that differently? Absolutely. Share the results is also very good. So absolutely positively make sure that you can easily list the 4 steps of the scientific method. So on the previous slide, I mentioned these cautions. Again, one-word answers will be marked wrong if it's discussing the scientific method. A hypothesis must be a statement, not a question. It must be specific. I often have students who say that one thing affects the other, and unfortunately they don't receive credit. You have to be specific. But here's a question for you. For step 2, we said you do not have to put gather data or test hypothesis. What if a student puts do an experiment? Do you think they'll receive credit or not? Unfortunately, this student would be marked wrong, and very commonly on tests, 25%, 30% of the class would get marked wrong on this particular step. Why is this not correct? It says do an experiment, which means you must do an experiment. But what if the person wants to do a correlational study, a survey method, and so on? So your answer must include all the possibilities. If you say gather data, that includes all the possibilities. If you say test your hypothesis, that includes all the possibilities. So your answer must be inclusive. So do an experiment only limits you to an experiment. So you would not receive the credit. So again, caution on your test. Here's our scientific method again, with a specific example and pictures for the visual people. The first step, he is developing a hypothesis. Apparently, the effects of sugar on activity levels. Second step, gathering data. Apparently, observation was chosen. 3, analyze the results. And 4, apparently he was able to publish in the Journal of Psychology. You'll notice that it introduces the term replication, which we'll discuss on our next slide. After the study is published, other scientists will try to replicate the results. In other words, they will redo the study to see if positive results occur again. Why is this necessary? Well, let's say that we have a study that looks at a particular drug and apparently is very effective. Would we want to make this drug approval, the maybe preferred drug based on one study? What if this was a fluke and would not be replicated again? Or conversely, maybe we find a new educational technique that looks effective based on one study. Would we want to spend millions of dollars and institute it across the country based on one study? And perhaps those results were a fluke and could not be replicated. So once it's like a potato chips, definitely not enough. So replication and expansion is part of the scientific method. Let's see how well you're doing on this hypothesis topic. Read the slide and note these 3 examples. Are they all good hypotheses? None of them? Some of them? So identify the true hypothesis or hypotheses. Our first example has a question, not a statement, so that is not a hypothesis. I often see questions on tests. The next one is prediction, statement, specific. It is an excellent hypothesis, and we can test it. The third one, much too vague, so it would not be a good or testable hypothesis. I did have a motive for choosing that particular hypothesis. I just wanted to reiterate some of the support services offered by the college. Take a moment and think of as many as you can. There's a huge number, all designed to help you reach your goals. If you look on Blackboard under Services, you'll see this particular page come up, and this lists some of the services available to you at the college for free. If you're interested in counseling, our counselor is excellent, Mrs. King, and you'd have to click under Wellness. Let's see, that is located on the first block, second from the bottom, Wellness and Support Services, so you can make an appointment online. Not on this list because it's outside the college is Blackboard, or in other words, SLN Helpline. They're open 7 days a week and often into the evenings. So if you have any Blackboard issues, such as when you're taking a quiz or test, or having trouble listening to audio, these are the people to talk to. They are experts, and you can talk live. You do not have to text unless you really want to. Now that I've snuck in that little public service announcement, let's return to our task of the scientific method. Look at these 3 students, student A, student B, student C. Look at each answer and see if you think that would be acceptable or not for a test. Let's look at student A first. Step 1, great. Step 2, big problem, too specific. It leaves out many research methods. 3, fair enough. 4, also good. For student B, number 1, much too lazy. What about the hypothesis? That would not receive credit. 2, fine. 3, fine. 4, also fine. Student C, 1 is good. 2 is vague enough. It's also good. 3 is good. And 4 is good. So make sure that you, if asked this question on a test, would be able to do it easily. It will not be sufficient for a course to just be able to create or recognize the steps of the scientific method. You'll also be able to need to create a hypothesis on your own and then apply the concepts learned when we discuss the experiment. So let's start here. Create a hypothesis about the content of this particular slide. So I'll go for a serious one that actually matches research, but yours just has to fit the criteria of being a hypothesis. A serious one would be that people that are sleep deprived will consume higher amounts of junk food. It's specific and it's testable. Before we look at specific research methods, we should introduce ourselves to the ethical guidelines that we must follow when doing experiments. Let's start with IRB. This is an acronym that you absolutely positively should know. It stands for Institutional Review Board. And yet when I ask it on test, I get all sorts of different words for I, international, internal, and so on. You know, every college and every research facility has an IRB. SCCC has an IRB. I was actually 50% of it back in the day. Albany has an IRB. Siena has an IRB. St. Rose has an IRB. So think of the different colleges around us, including ourselves. Institutional Review Board. They must approve of psychological research before it's conducted. So they'll look at the proposal. Maybe they'll ask it for it to be changed. Maybe they'll think it's good as it is, or maybe they'll outright reject it. Now let's look at informed consent. It's got three components. One is we must tell you what we can about the experiment. It might not be a whole lot, but we must inform you about the details of the experiment. Second step, you must be told that you have the right to decline. You have the right to refuse to participate. Rather like marriage in our culture, just because you're asked, you do not have to say yes. The third one, even in the middle experiment, you can change your mind. You can withdraw, which is also rather like marriage in our culture. So you must be informed about as much as we can about what will happen in the experiment. You must be told that you have the right to refuse to participate. And you must be told that you have the right to quit, to withdraw, even after the experiment has begun. If you agree to all that and sign your name on the dotted line, not only do we have your consent, but we have your informed consent. You were informed, and then you consented. It's rather like medical informed consent. They tell you every possible bad thing that could happen. You still want the surgery? Go ahead, sign on the dotted line. They too have your informed consent. Let's consider the topic of deception and debriefing. Can modern-day psychology experiments use deception? Many of my students are quite surprised. Yes, indeed, deception is allowable. A placebo pill is deception. The control group is deception. So yes, deception is allowed. You must convince the IRB that it's necessary. Now, if you deceive, you must follow that with debriefing. Debriefing means that you tell the people in the experiment the deception was used and why you thought it to be necessary. So again, deception is permissible, and debriefing must occur. Next one, confidentiality. If you know what that word means in any context, it's the same here. So we're not allowed to share that you were in the experiment. We're not allowed to share what we found about you. You'll be subject A, subject 972, or so on. So it'd be like calling for your doctor and asking, is so-and-so a patient? Is so-and-so being treated for whatever condition? They are not allowed to say confidentiality. What are some good synonyms? Well, maybe private, anonymous comes close. Last one, protection from harm. Psychologists are obligated to protect their human subjects from harm. That protection from harm includes physical as well as psychological harm. So you should not be physically scarred or mentally scarred from being in a psychology experiment. So those are some of the most basic ethical guidelines that researchers are obligated to follow. Let's consider animals in psychology research. On the first day, we learned the approximate percentage of experiments that use animals. It surprised many students to learn that it's somewhat less than 10%. We rounded to 10 though. So let's say that I think you all have way too little work to do, so I ask you between now and the next time you sit down to do the slides to review 100 psychology experiments, all using animals. What sort of animals would you think would be most commonly used? Think of as many as you can, and then think of the most common one. So perhaps you said rodents, which includes rats, mice, guinea pigs. Are rabbits rodents? No, they're legumivores. So rodents, rabbits, great apes, monkeys. I worked with chickens as well as rodents. What would be the most commonly used animal? Well, by far, it would be rodents. Almost all psychology experiments that use animals use rodents. Now, don't get confused though and think that the most commonly used subject is a rodent. No, almost all psychology experiments use people. Of the small number of that 10% or less that use animals, those would be primarily rodents. Now, you might notice on the previous slide when we were talking about humans, I said that the psychologist is obligated to protect his or her humans from harm. Are we obligated to protect our animals from harm? Ponder that for a moment, if you will. It might surprise you to know that no, we are not obligated to protect our animals from harm. Most experiments result in the sacrifice of the animal. Polite language for euthanasia. And if you object to that, would you want all of SUNY Albany's rats living in your house with you? If you do, perhaps give them a phone call. But again, sacrifice, euthanasia, is harm. Now, the researcher will do everything that they can for ethical and practical reasons to minimize animal stress and suffering, but still, euthanasia is often the end result of animals, at least rodents in psychology experiments. So at this point, we've reviewed the scientific method. We've learned how to construct a good hypothesis. We've talked about ethical issues of use of people and animals in psychology research. Next, it's time to actually look at the most used research methods in psychology. One last step before we look at the specific research methods, we have to discuss sampling, which will include both population and samples. A few terms. I'm going to use a four-word definition for population. It's as short as I can get it. Population, entire group of interest. Students often try to make it into something it's not. It's not everybody, everywhere. It's an entire and also specific group of interest. Maybe one researcher is fascinated by girls with ADD. Another researcher looks at elderly people with ADD. Maybe another researcher studies people on the spectrum that have a gender identity disorder. Maybe another researcher looks at people with Alzheimer's. Maybe another researcher looks at more specifically people with early onset Alzheimer's. So population isn't everybody everywhere. It's the entire and specific group of interest. Usually way, way too many people to be in one experiment. It could be thousands, tens of thousands, or millions. So instead of having the entire population in our experiment, we'll settle on a sample, a subset. All samples are subsets of the group of interest. How else could we say that? All types are subsets of the population. We will discuss on the next slide the three basic types of samples. So let's consider the three basic types of samples. To make your life easier, I'll start off each definition with the same phrase, since all three are for samples. Let's start with representative sample. It is a subset of the group of interest, or if you prefer, you may put a subset of the population, which is structured exactly like the group of interest. Let's consider a famous example. Back in the day, and I'm being specifically vague, there was a presidential runoff happening against two individuals. A magazine called the Literary Digest contacted many, many thousands of people from across the country and tried to determine who was going to win the election. They asked simple questions, either by phone or by postcard, asking, are you registered? Are you planning on voting? Who are you going to vote for? And virtually everybody they contacted said Alf Landon. Are you familiar with President Landon? Probably not. He ran against Franklin Delano Roosevelt. So obviously this Landon fellow did not win by a landslide. He lost by a landslide. Let's consider their methodology. Again, calling people randomly on the phone, sending out random postcards. What would determine that outcome? Take a moment and think about it. Well, the time period was the 1930s, the time of the Great Depression, in a time period when everybody was very, very poor, at least almost everybody. The researchers, the Literary Digest that is, accidentally contacted almost exclusively rich people. Now, back in the 30s, the Republican and the Democratic Party is pretty much flipped in terms of where they are today. So the Republican Party was the People's Party. The Democratic tended to be the more well-to-do people. So anyway, the people who had phones were very well off. They were the people interested in Alf Landon. The people who with cars were well off and registered legal cars, so you have money to burn. They were also very interested in Alf Landon. Versus the average person was not being contacted at all. They didn't own a car, they didn't own a phone. So in a time period which about everybody back then was Republican and very poor, they accidentally contacted almost exclusively Democrats. So the sample was not representative. It was not structured like the group of interest. They wanted the typical voter, they got the typical ultra-rich voter. So you can see the importance of having a representative sample. Now let's consider momentarily the random sample. So as you can see, we'll start our definition the same way, a subset of the group of interest, or if you prefer, a subset of the population in which all members had an equal chance of being picked. And doesn't random mean equal chance? Think of some phrases, if you will, that have random in them. Well, if you buy a lottery ticket, you hope it's a random drawing and not a fixed one. Maybe you could receive a random act of kindness. Everybody's got an equal chance of getting that. Or a random killing. You certainly don't want to receive that, but you could. It is random. So random means equal chance. Now let's consider the third type of sample, biased. We'll start our definition the same way, a subset of the group of interest, or if you preferred, a subset of the population, but which is not, and make your not in your notes big and bold, not structured like the group of interest. So the Literary Digest was trying for a representative sample. They thought they were using random sampling to achieve it. They did not. What they ended up with is a bias sample. You never set out to get a bias sample. It's basically the oops factor. It's a bias sample. It is not structured like the group of interest, and its results are totally useless. So on a test, look at the words. Random means equal chance. Representing means it does a good job of representing the larger group, and biased is the bad type of sample. If you remember that, you'll have no trouble on any question I could possibly throw at you. We'll now start looking at the 5 main types of research methods of psychology. This is not an exhaustive list, but it has the major players. So let's go to our next slide and start with a case study. Let's define the case study as an intensive investigation of a rare phenomenon. If you don't like the word phenomenon, right thing, in a person. Many of psychology's most famous case studies are on the topic of multiple personality disorder. Can you think of any of these? Take a moment. Sybil is probably the most famous one. It was a movie with, after it was written, of course, it became a movie with Sally Field. She was Oscar nominated for it. Another famous, and I remember reading that as an undergraduate. I moved on to another famous one after that, Three Faces of Eve. You can certainly guess how many personalities Eve had. Another famous one, When Rabbit Howls. I'll admit, Rabbit, by the way, was one of the personalities. When Rabbit Howls, I didn't read that one. I had lost interest by that point. But again, these are examples of case studies on multiple personality disorder. But certainly, multiple personality disorder is not the only topic of case studies. Have you ever heard of Jeannie? As a young child, about age 3, her father decided she was intellectually disabled and must go to the attic. I don't understand the logic either. She spent the next 10 years of her life in the attic. During the day, she was chained to a toilet. At night, they strapped her into their homemade straitjacket. She virtually never heard any language. She was barely fed. She could not stand upright unsupported when they found her at age 13, had no language skills, and was the size of a young, maybe 5 or 6-year-old. Thank goodness this is not a standard way of rearing children, but if you want to find out what happens to children in this cruel and unusual circumstance, you better do a case study. You better get as much information as you possibly can, because who knows when you'll see this again. Hopefully never. Have you ever heard of Phineas Gage? He was a Vermonter who was in a very unusual accident. We'll watch a little bit of a reenactment of his accident later in the course. Just to give you a little bit of details, a 3-foot, 13-pound metal rod was shot through one side of his skull and out the other. He survived, but worse for the wear. My last example of a case study would be described in a book of case studies called The Man Who Mistook His Wife for a Hat. It's a famous collection by a neurologist, very famous neurologist by the name of Oliver Sacks. In this particular case study, the man was a PhD, a musician, and he developed an unusual problem. Conversationally, he was perfectly normal, but when he looked at anything, he could not recognize it. But again, intellectually, he was fine. Eventually, he crossed paths with Dr. Sacks, and they had a long conversation about all sorts of subjects, and then they got down to business. Dr. Sacks showed the gentleman several objects to identify. He could identify none of them. Then Dr. Sacks asked him to describe the objects. Let me give you one of the descriptions and see if you can figure out the object that our man who mistook his wife for a hat was trying to figure out. He looks at this common object and says, could be a container of some sort. Clearly he's not clear on this. He says it has 5 outpouchings, and he adds, if outpouching is even a word. So can you think of things that always have 5 outpouchings? Common suggestions I get from my students are briefcases. Well, they don't have outpouches. Pockets in pants, no, they're not outpouches. A hand, no, that doesn't have outpouches, but that's close. A glove, 5 outpouches. He accidentally puts it on his hand and says, oh my God, it's a glove. So clearly he could see the object, but he could not interpret it. The issue was a very large tumor in the part of his brain that should have dealt with visual information, which unfortunately for him was on a permanent vacation. They concluded their interview, and as leaving the office, Dr. Sacks walked him off to the office. The man went up to his wife and grabbed her head and tried to lift it. He thought her head was his hat. I loved his description, that is Dr. Sacks. By the looks of the woman's face, this was not the first time that this had happened. And so the book was titled, after this particular case study, The Man Who Mistook His Wife for a Hat. So again, intensive investigations. So you want to get as much information as you possibly can. Maybe do an IQ test, a personality test, an MRI, interview them, interview people that know them, and so on. Because these are all ultra rare opportunities, so you need to get as much information as you possibly can. And that is the essence of a case study. Do you recognize this very famous researcher? This would be Jane Goodall, presumably at the Gombe Reserve in Tanzania. Observation can be of people or animals, and the person can interact with the observees or not. Typically not, though. This, I presume, is a group of orphan chimpanzees, because Dr. Goodall did not typically interact with her wild chimps, but they would receive so many orphans that were killed, whose mothers were killed in the process of poaching. So observation, again, can be people of animals. It can be a natural setting or a laboratory, and the researcher can interact with the subjects or not, but typically not. And simply the observational data is recorded and analyzed. And there you have it, the method of the observation. Let's now turn our attention to the survey methods. It's a collection of methods which includes questionnaires, polls, interviews. It's particularly useful if our goal is to learn about opinions and beliefs. Survey methods are used quite a bit, though not necessarily in psychology, but in many disciplines. Even though they're used quite frequently, there are many problems associated with the survey methods. Let's, for example, say that I'm a sex researcher. I do teach human sexuality typically every year. So let's say I choose to do a survey method and to learn about a particular subject topic. What sort of problems might I come across in using the survey methods to learn about some aspect of human sexuality? Think for a moment and see if you can come up with some of the problems of this method. Did you say dishonesty, lying, stretching the truth? That is a significant issue. Also, poor sampling. Perhaps the researcher had some sort of biased sampling issue. Or perhaps a researcher is lacking skills. Maybe their interview skills are poor, or maybe their item construction on their survey is poor. Next, you call poor memory, or I'd also accept human memory. The longer the past, the less accurate the memory would be. And also poor data return, and poor data return would lead to, of course, issues in sampling. So they are definitely tied into each other. So If these problems are avoided, survey methods can provide good data, but the researcher has to avoid all these issues and more to get useful data. Let's now consider a study called the correlational study. Its purpose, prediction, when we want to be able to predict one variable from another. There are three types of correlations that might come about if we did correlation research: a positive correlation, a negative correlation, or a zero correlation. So let's consider these three types of correlations. For a positive correlation, let's say that we will predict, remember correlations are all about prediction, we predict this one variable increasing. What do you think the other one will do? It will also increase typically. And any guesses on the end? So as one variable increases, the other usually increases, and if one decreases, the other usually decreases too. So as one goes up, the other tends to go up. As one goes down, the other tends to go down. For a negative correlation, we will predict, remember correlations are all about prediction, we will predict that as one variable goes up, what do you think about the other? Yes, it typically goes down, and vice versa. So as one goes up, one goes down. Here's a question for you as we consider the zero correlation. What about prediction for a zero correlation? Consider that for a moment. So if we have a zero correlation, it means we have a zero ability, in other words, no ability to accurately predict one variable from the other. So remember, correlations are all about prediction. So zero correlation means no predictable relationship. Now, it's a fairly good bet in any class if you're given a definition, the teacher expects you to know it. But that being said, it's quite possible for a student to memorize the definition but not be able to apply it. So my questions often tend to be applied. And it is hard, I admit, to hold that definition in your mind and then apply it. So I'll give you a little trick that makes your life easier, I would hope. It just involves turning our definition into symbols. So consider a positive correlation. Which of these would match a positive correlation? Think of the definition. So if you see words like increases, larger than the average, the arrow would point up. Decreases, smaller than average, the arrow would point down. So again, which of these would be for a positive correlation? Also, while you're at it, identify the negative correlation pattern and the zero. So for the two arrows going down, that would be part of the definition for positive correlation. Remember, as one goes up, the other goes up, and as one goes down, the other goes down. So the arrows pointing down are part of a positive correlation pattern. The next box over, also part of a positive correlation pattern. If you're drawing your, and when you look at your example, draw the arrows right on top of the words like increases, decreases, and you should easily get one of these patterns. If you get three arrows, go back, you've lost one. For the question marks, if you can't possibly find a way to draw arrows, that would be the zero pattern. And for the last set of boxes, one going down, the other up, that's part of a negative. One goes up, the other goes down, also part of a negative. So basically, we just turned our definitions into arrows, and we read the verbal example, we'll put the arrows right on top of the appropriate words, such as going up, going down. Next slide, let's actually put this in operation and see if it works for you. Oh, before I move on to the next slide, so remember, if there's three arrows, you're missing one. And sometimes when you see the applied question on the correlation, you'll get the choices positive correlation, negative, zero, or both. Never go for both. Can't be both. Both is like a very tall, short person. Can't be both. It's one or the other. So for this slide, please read the examples. And after you've memorized your types of correlations in each space provided, draw an arrow pointing up or down, and then use that to determine what sort of correlation we have. And again, you might have to study correlational types before you can do this applied slide. Exercise and depression. Research finds that people who have exercised a lot, so your arrow would be pointing up, had lower rates of depression. Arrow pointing down, one arrow up, one arrow down, that would be a negative correlation. And this is actually what research finds. Current research is finding for major depression, exercise can be nearly as effective as antidepressants without harmful side effects. Let's consider the next one, foot size and psychology grade. Researchers find no predictable relationship between the two. So that would be a zero correlation. So a teacher, I will say, oh, look at her tiny feet. She will be my best student. Or look at his big feet. I'm glad he's got a great personality. He'll never pass. I'll never make those assumptions because there's no predictable relationship between foot size and psychology of class performance. Let's consider the last set, caffeine and memory ability. People given high doses of caffeine, hopefully you did your arrow up, recalled more items, hopefully arrow up again. Those given low doses of caffeine, arrow down, recall less info. So up, up, and then down, down, the pattern for a positive correlation. Now, some students get confused and they think positive means good, negative means bad. No, that's just in terms of when you do the research, you put your data into your statistical formula, you analyze it, you'll either get a positive number, which would tell you it's a positive correlation with the pattern that we know goes with it, or if we get a negative number, well, that tells us we have a negative correlation, and we know the pattern that's associated with that. So positive and negative has nothing to do with good or bad, just has to do with the number you get when you solve your mathematical formula. If you're taking statistics, I assume that you'll do a couple correlations in that class. So again, as we've learned, positive and negative have nothing to do with good or bad. It has to do with our data. So in the first example, if we graph the data and saw this pattern, that would indicate there's a positive correlation between those two variables. As one goes up, the other gets up, and if one's a smaller in one, it will tend to be smaller on the other. B is a negative correlation. So if one variable is high, the other one tends to be very low, or if you're looking at a very low one, its corresponding data point would be very high. So you can see the pattern of data points for a negative correlation. For the third example, they chose height and GPA. No predictable relationship. Knowing one does not help you predict the other one whatsoever with any degree of accuracy. And you'd see a pattern that's just random, and thus you could not draw that line of best fit, which you can easily do with a positive or negative correlation. Let's do a couple more examples, because I assume that you're still learning the concepts, and that's fine. So parents who frequently praise their children for being intelligent have children who are less willing to do new things. So put in your arrows and determine what type of correlation you have. So the first blank should be an arrow up, second blank should be an arrow down, one up, one down. That would be the pattern we observe for a negative correlation. Are you surprised? Much research is out there suggesting praising children for intelligence is harming them, not helping them. Then how should we praise them? We can learn that from the next slide. Let's try this example. Parents who give high amounts of praise to their children for working hard had children who were more willing to try new things. So draw in your arrows and determine what sort of correlation you have. So in the first blank, since there's high, arrow up. Second blank, high, so they're more willing. So high score and high score, that would be positive correlation. So much research says don't praise your children for being intelligent because they like being praised. And if they get things wrong, you won't call them intelligent anymore. So they've got something to lose by trying new things. But if you praise your children for working hard, there's no harm in trying and failing. So if you praise children for working hard, they are more willing to try new things. Let's now consider the experiment. We're really not supposed to have a favorite research method, like people are not supposed to have a favorite child. But in this case, I think it's okay. This is our favorite research method because it is the only research method, note the caps, meaning it's highly important. It's the only research method which allows us to draw cause and effect conclusions, to say this thing causes the other to happen. In a correlational study, you can do prediction, but you can't conclude that one variable is causing another. Let's consider an example. Let's say that I'm hired by a business to correlate two interesting variables: ice cream sales for every day in a year and deaths by drowning. And I find that there is a predictable correlation. On days where there's lots of ice cream sales, there tends to be more drowning. On days with very few ice cream sales, there tends to be less drowning. Are you willing to say that when people drown, people go out and have ice cream parties? I hope not. If you eat ice cream, you're likely to flop around the floor and drown? Obviously not. So you can see that one can be predicted from the other, but what is causing the relationship? It's a third variable if that's a hint. So on days with high ice cream sales, it's harder. When it's hotter, more people tend to swim, and not everybody swims as well as everybody else, so we have a higher rate of drowning. On cold days, people are less inclined to eat ice cream, and people are less inclined to swim, and therefore not risking drowning is greater frequency. So clearly, it's the temperature which is causing the relationship, not the variables directly influencing each other. So the point is that even if there's a predictable correlation, positive or negative, you cannot assume that the variables caused the change in the other one. Maybe they did, maybe they didn't. The correlational study has no way of determining that information. If you want to do cause and effect, you better do an experiment. So let's look at the basic components of experiment, those elements which eventually allow the cause and effect conclusion to occur. Two types of variables, two types of groups. Take a moment and see if you can identify both the groups and the variables. So the variables would be independent and dependent. The groups, experimental and control. Make sure you don't call it the experiment group and the control group. You're extremely likely to be marked wrong. In particular, it's problematic if you call it the controlled group. That's not a spelling error, that is a conceptual error. Calling something controlled sounds like it's being controlled, which is not the case. It gives control, it gives power. So again, the answer would be experimental and control group. So now let's learn our terminology, which is specific to the experiment, starting with variables. The independent variable, IV if you want to abbreviate it, is the treatment. Next time you get a prescription, if it's a paper one, look on it and you'll see an RX. That's the abbreviation for treatment. So it might be medication. It might be a new study technique. It might be a new form of exercise. So it's a treatment. And we'll learn that half the subjects will get it and half will not. But in any case, the independent variable is the treatment. The dependent variable is the measured outcome. As a mnemonic, which might help you out so you don't confuse the two, the outcome is dependent. The outcome is dependent on everything that goes on in the study, which group you're in, if you get the treatment or not, if the treatment works. So the outcome is dependent, so it is called the dependent variable. Now, caution here, on your first test, you'll probably have two different hypotheses, and for each one, you'll have to also design an experiment indicating the variables and the groups. When you choose your dependent variable, don't confuse it with the results of the study that you run. For example, if we were going to look at maybe the effects of exercise on weight, for the dependent variable, it would be weight. You wouldn't put weight loss because you don't know until you run the study if there will be weight loss. You choose a dependent variable before the study is run. If you're looking at insomnia, your dependent wouldn't be a reduction in insomnia. The dependent variable would just be a quality of sleep. So again, dependent variable is the outcome, and we establish the outcome measure before we run the study. And if I lost you there, it's okay. We're going to practice it on the next couple slides. Before we're ready to apply our terms, we have learned the other set of terms, the groups. Experimental group. They're the subjects who get the treatment, whatever that treatment might be. It might be medication. It might be a new study technique. It might be exercise. You get the idea. It's the treatment. So if they're getting the treatment, they are the experimental group. The control group, well, they would be the subjects who do not get the treatment. They're treated alike in every other way, so if the experimental group gets a pill, the control group gets a placebo pill, and so on. So we need the control group for comparison. What would happen if the people didn't, or the animals didn't get the treatment? So in psychology, there's haves and have-nots. Sometimes it's better to be in the have-not group, sometimes it's better to be in the have group. But now let's apply this and see how we do. We finished the new material for this particular chapter. Before we go on to our next chapter, let's please verify that we understand the concepts of hypothesis, variables, and groups quite well. You will get multiple applied questions on your first test on this particular subject, as well as on your test 2, test 3, and the final. So it's better to learn now than later. So please review those appropriate sections of your notes, and when you think you have learned and memorized the terms as needed, see if you can apply them on this particular slide. So let's see how you did. Independent variable, it is the treatment. Dependent variable, it is the outcome, or you can say the measured outcome. Experimental group, the ones that get the treatment. Control group, the ones that do not get the treatment. For 2, the variables, the drug level is the independent variable. Level of aggression is a dependent variable. As a mnemonic, think of the dependent variable as being the outcome. So the level of aggression is the outcome that depends on everything that goes on in the experiment. So the level of aggression is the dependent variable. Groups, well, placebo group would be the control group. The drug group would be the experimental group. What research method was used in A and B? The experiment. Which research methods have both variables and groups? Again, the experiment. And the last question, what advantage does the experiment have over all the research methods? It is the only one that can determine causality, or perhaps you said the only one that allows you to draw cause and effect conclusions. Very good. If you had trouble, please go back and review, and when you think you're sufficiently prepared, go to the next and last slide of the chapter. Please use the slide to assess your knowledge of hypotheses, groups, and variables. You will need this knowledge for all 4 tests of this particular course. So for number 1, perhaps you hypothesize that high levels of body or brain caffeine would be associated with greater morality in decision making. If you chose that particular hypothesis, for number 2, you'd have to put independent and dependent variable. The independent variable would be the level of caffeine subjects are given. The dependent variable would be the degree of morality in their decision making. The groups would be experimental and control group. The experimental group would be the subjects given caffeine. The control group would be the subjects not given caffeine. For number 4, perhaps your hypothesis was subjects given the drug created by aloxicam will have decreased social anxiety levels. If that was your hypothesis, then number 5, you would identify independent and dependent variable. Independent variable is a treatment, so it would be the drug. The dependent variable would be social anxiety levels. For number 6, you identify the groups, experimental group and control group. Experimental group would be the subjects that were given the drug. Control group would be the subjects who were not given the drug. Just as a small point that would affect your grade on a test, make sure when you're doing the dependent variable that you don't say the results of the experiment. So in this one, the dependent variable would be social anxiety levels. You can't say increase social anxiety levels. You can't say decrease social anxiety levels. We only know that after we run the experiment. The dependent variable is determined when the experiment is designed. For number 7, our last question of the chapter, you're going to construct a hypothesis. Perhaps you hypothesize that sleep deprivation will be associated with lowered student academic success. Or perhaps you put a specific number. Students that are sleep deprived, sleeping less than 7 hours per night, will have decreased academic success. And actually quite a bit of research does associate declined functioning, including academic levels, with sleep deprivation. If you're curious about morality and caffeine, I didn't pick that out of a hat. People that are caffeinated actually make more moral decisions. If you look at the time of day and moral decision making, people make their best moral decisions in the morning when they're the most caffeinated. So if you're doing business, perhaps morning is better than the afternoon.